Welcome to a deep dive into the revolutionary propulsion physics of the AEON CASIMIR initiative. In this chapter, we explore how inertial mass engineering and frame control are transforming our understanding of movement and acceleration. Traditionally, propulsion has been limited by the resistance of inertia, but what if we could engineer inertia itself? This is the question at the heart of Colonel James Hartman's work in Northwest Indiana, where the boundaries of classical and relativistic mechanics are being redefined. Let's begin by understanding why inertia, not force, is the true limiting factor in advanced propulsion systems. Classical mechanics, the equation F equals ma tells us that force equals mass times acceleration. However, when acceleration increases while mass remains fixed, internal stresses within a structure can become catastrophic. This is especially true at high speeds or under extreme maneuvers. The AEON CASIMIR approach seeks to overcome this by not just applying more force, but by engineering the inertial term itself. This means that instead of fighting against inertia, the system redefines how inertia behaves, opening up new possibilities for movement and control. General relativity teaches us that inertia is not an intrinsic property of matter. Instead, it emerges from the context of local spacetime curvature, stress energy distribution, and vacuum energy density. This means that inertial mass is not absolute, it can be influenced by its environment. The AEON CASIMIR system exploits this non-absoluteness, allowing for the manipulation of inertia through engineered changes in the vacuum itself. This marks a fundamental shift from traditional propulsion concepts. Formalize this new approach, AEON CASIMIR introduces the effective inertial mass tensor. Unlike the traditional scalar mass, this tensor is direction-dependent and is influenced by the engineered vacuum potential and the local metric tensor. This mathematical framework allows inertia to be modulated in real time, adapting to the needs of the craft and its environment. The result is a system where inertia is no longer a fixed barrier, but a controllable parameter. The engineered vacuum potential changes over time, the effective mass of the craft can be reduced below its rest mass. This leads to a dramatic reduction in inertial resistance, enabling extreme acceleration without the usual force feedback or internal G-loading. Importantly, the rest mass remains unchanged, energy conservation is maintained, and no exotic matter is required. This breakthrough allows for safe, rapid maneuvers without risking structural integrity. Despite these advanced manipulations, the AEON CASIMIR system remains consistent with Newtonian mechanics at all scales. In the Newtonian limit, force equals effective mass times acceleration. The key difference is that the effective mass can now be modulated, allowing for apparent instantaneous acceleration, silent maneuvering, and hovering without traditional lift surfaces. Direction changes can occur without lateral forces, making the craft's movements appear almost magical. One of the most striking features of AEON CASIMIR propulsion is its independence from Mach number. Because the system does not rely on pressure differentials, exhaust plumes, or airflow coupling, the craft experiences no sonic boom, no shock cone, and no drag-induced heating. The slip layer, introduced in the previous chapter, ensures that the external flow is completely decoupled from the craft's motion, enabling truly silent and efficient flight. Key maneuver capability enabled by AEON CASIMIR is inertial frame rotation. By rotating the inertial tensor, the craft can turn without experiencing centripetal force. Occupants feel zero lateral acceleration, and structural loads remain near zero. This explains how the craft can perform right-angle turns, sudden stops, and zigzag motions that would otherwise violate classical flight envelopes. The result is a level of agility and control previously thought impossible. At extreme field gradients, the AEON CASIMIR system remains stable. Casimir modes are phase-locked, plasma oscillations are harmonic, and metamaterial lattices suppress decoherence. This means that even under intense conditions, the system self-stabilizes rather than diverges. High-energy maneuvers can be performed safely, with the craft maintaining full control and integrity throughout. Even the most advanced systems must account for failure. In AEON CASIMIR, inertial failure can occur if vacuum coherence collapses, boundary phasing delocks, or plasma resonance drifts. However, even in these cases, the system simply reverts to Newtonian inertia. There is no catastrophic failure or explosive energy release, ensuring the safety of both the craft and its occupants. Perhaps the most groundbreaking aspect of AEON CASIMIR is its ability to enable propulsion without traditional thrust. By redefining inertia, the system allows for movement and acceleration without the need for reactive forces or exhaust. This opens up entirely new possibilities for vehicle design and operation, especially in environments where conventional propulsion is impractical. In CASIMIR, acceleration can occur without the application of traditional force. This is achieved by modulating the effective inertial mass, allowing the craft to change velocity rapidly without subjecting its structure or occupants to harmful stresses. The implications for high-speed travel and maneuverability are profound, making previously impossible feats routine. Traditional vehicles are limited by the stresses imposed during rapid maneuvers. EON eliminates these limitations by ensuring that all known physical laws are preserved while allowing for stress-free maneuvering. This means that the craft can perform complex movements without risking damage or discomfort, greatly expanding its operational envelope. This chapter mathematically closes the propulsion loop that was opened in earlier chapters. By redefining inertia and integrating it into the field architecture, EON CASIMIR provides a complete and consistent framework for advanced propulsion. Every aspect, from acceleration to stability, is accounted for within the laws of physics, ensuring both theoretical soundness and practical reliability. Implications of EON CASIMIR's inertial engineering are vast. Future craft could be designed without the constraints of traditional propulsion systems, enabling silent, efficient, and highly maneuverable vehicles. This technology could revolutionize not only aerospace, but also terrestrial and marine transportation, opening up new frontiers for exploration and travel. Common misconception about advanced propulsion is the need for exotic matter. EON CASIMIR demonstrates that by manipulating the vacuum and effective mass, all of these effects can be achieved without resorting to unknown or unstable materials. This makes the technology not only more feasible, but also safer and more reliable for practical applications. Despite the radical changes in how inertia is managed, EON CASIMIR ensures that energy conservation is always maintained. The system does not create or destroy energy, it simply redirects and modulates inertial effects. This adherence to fundamental physical laws is crucial for both scientific acceptance and operational safety. One of the most significant benefits for occupants is the elimination of internal G-loading. Even during extreme acceleration or rapid maneuvers, those inside the craft experience no harmful forces. This not only improves comfort, but also expands the range of possible missions and applications, from high-speed travel to delicate scientific operations. Structural shear is a major concern in traditional high-performance vehicles. EON CASIMIR's approach ensures that even during the most demanding maneuvers, structural loads remain near zero. This drastically reduces wear and tear, extends the lifespan of the craft, and allows for lighter, more efficient designs. Ability to perform right-angle turns, sudden stops, and zigzag motions is a direct result of inertial frame rotation. By decoupling the craft's motion from traditional inertial constraints, EON CASIMIR enables maneuvers that would be impossible for conventional vehicles. This capability could redefine what is possible in both civilian and military aviation. Summary: the EON CASIMIR initiative does not fight against inertia, it redefines it. By engineering the inertial term and leveraging the properties of the vacuum, this system enables propulsion, acceleration, and maneuvering without the traditional limitations of force and stress. All known physical laws are preserved, and the potential applications are vast. This chapter closes the mathematical and conceptual loop, setting the stage for a new era in propulsion physics.